Today we are back in Universe Sandbox and I'm letting my chat pick what we do. And today we're gonna start by replacing Earth with a black hole that has the same mass as Jupiter. If you wanna see these live, make sure you join the Twitch. The link will be in the description. I hope you enjoy. Turn Earth into a black hole with the mass of Jupiter. Let's start with that. That sounds good. All right, here we are in our solar system. We could either turn it into a black hole and then grow the black hole, or we could grow Earth and then condense the mass into a black hole, if that makes sense. I think we should grow Earth first and then turn that into a black hole. Earth, the mass of Jupiter. How's that gonna affect the system? The prediction will there be a noticeable effect on the planet's orbits? So if the other planets are noticeably different in their orbit, it's a yes. And if we can't really tell, then it's a no. Deal? All right, let's get started with this. Most people think no. I agree with that. But let's see what happens. Earth. Okay, so the suggestion is make Earth a black hole the size of Jupiter. Okay, I want the time slow. So we want this to be 1 Jupiter's mass. It's gonna turn into a gas giant. There's no way it stays rocky once we get really big. Oh, maybe? Okay, 1 mass of Jupiter. Still rocky. Okay, interesting. Earth is now the mass of Jupiter. What's the life likelihood? That pretty much killed everything. 0.02% chance of life. Now that it is the mass of Jupiter, we're gonna crush it, but we need to make sure the mass stays the same. So the way we do that is lock the mass, and then this is just crushing it. So all the mass is still there. Whoa, okay, Earth is not having a fun time. I can already tell you that, dude. Keep crushing. Keep going. Poor Earth here. Going through it. At what point does it turn into a black hole? Yo, how small does it have to go? 40 meters. Earth is 40 meters. 10 meters? Okay, at 1.8 meters, Earth finally turned into a black hole. It has all of the mass of Jupiter though. So imagine Jupiter, you take everything that's on Jupiter and you crush it down to only 1 meter. Like that's how dense black holes are. All right, so the prediction was, will the other planets be affected by this? Let's zoom out and we'll speed up time and see. We're looking for a noticeable difference in the orbits of at least one other planet. It looks all right, because like, obviously, yeah, it's a lot more massive, but imagine like Jupiter's out here and our system is still stable, and this has the same mass as Jupiter. That looks stable to me. All right, the prediction is a no. The orbits are not affected. Okay, now let's see at what point are the orbits going to be affected if we start turning up the mass now of Earth. Okay, mass, turn this up. At what point is it going to start pulling on the planets? 5 Jupiters, maybe? Maybe that's doing a little bit. Let's keep going. Okay, 25 Jupiters. That's got to do something, right? Oh, yeah, that's definitely doing something. Oh, yeah. Okay, 25 Jupiters is going to mess our system up. I want it to consume the whole system now. Earth getting bigger and bigger, pulling the sun in until something's going to happen eventually, right? Okay, the simulation has to slow down. You can see the black hole there. Okay, well, obviously the system is definitely destroyed, like not doing well. Is it ripping particles off of the sun? Not yet, keep going. Oh, okay, there it goes. It has destroyed the sun and created its own like accretion disk in the center. Absorb the accretion disk and absorb, the whole system. Okay, there we go. Earth has killed everything. All right. That was our first suggestion, turning Earth into a black hole. Let's find another one. Replace our moon with Pluto. That's actually not that bad. Let's do that one. All right, we need to regenerate the solar system, bring it back to its former glory. Before we do anything, I just want to see a size comparison. So time is paused, don't worry. Pluto is smaller than the moon, and people think Pluto should be a planet. Look at this. Anyway, replace the moon with Pluto. All right, so now this is if Pluto is orbiting the Earth. Honestly, nothing's really going to change because like Pluto's smaller than the moon. Like it's not going to have enough gravity to affect Earth. So there you go. Now we get, instead of moon phases, what, we get Pluto phases. Can we see the Pluto phases? Whoa, chill. Slow down. There it is. What is the rotational period of the moon? It's a month, right? Because the moon phases go through every month, like 28 days or something. So this would be a lot quicker. I wonder if it's because the mass is less that to stay in the same distance, it has to orbit quicker. Interesting. Alrighty, that's pretty cool. But now, obviously, you know what we gotta do. Yes! Okay, goodbye, Pluto. Now Earth has no moon. Next suggestion, make a planet with 95+% chance of life. Oh, I feel like that's hard. Earth isn't even that high. Like, obviously, yeah, it's high, but you'd have to like recreate Earth. Cause look, life likelihood on Earth is 92.3. It's possible. I know it's possible. I just don't think I could do it. Do it? Should we try it? We'll try it. We'll give it a solid attempt. Let's just do a new system then. All right, obviously we're gonna use the sun because the sun is best for life. Random rocky planet at 1 AU away. All right, here's Journus. This is gonna be our Earth 2.0, okay? Mass, 1 Earth. Radius, 1 Earth. We want the density to be the same. Okay, it does feel like cheating, but you literally just have to copy Earth to get the highest life likelihood. Rotational period, 1 day. Let's see if we can do it. Obviously, water and an atmosphere. Very, very important. So let's go Earth, atmosphere, pressure, and composition. Go. Okay, so that should have given it Earth's atmosphere. You can see the life likelihood there. Now we need some water. Sea level. Probably mostly covered, you know? Because the Earth's, what, 70% water? Can I get planet above 95% chance of life? Okay, we have water. We have an atmosphere. It's at 64 right now. That's pretty good. Okay, so here's our magnetosphere. This protects the planet from solar radiation. Earth has one of these. We want the tilt to be correct. We want a little bit of a tilt, but not that extreme. So we still have seasons. 64.9. How do we make it higher? Oh yeah, the temperature. Okay, we want to make sure the temperature is good. 22.5, someone said. Is that better? Is that Earth's average temperature? 22.5 degrees tilt, not 22.5 degrees Celsius. I'm pretty sure like 17 is good here. 65.9. It's gonna be rough. What do we do? Okay, it's got water. It's got an atmosphere. Wonder if it's better to have a little bit less. 65.9, dude, it's impossible to get higher. Less CO2 gives us 65.9. Okay, our temperature is good. Let's just give it time and see if anything changes. Okay, it is slowly rising. Wait, hold on. Hold on. Okay, stabilized. Now it's going down. It's going down, guys. Add a moon? I mean, we could. How much does the moon affect life? How far is the moon out? Like, probably like that. No, it didn't do anything. Give it a little laser. Goodbye. Okay, well, we failed. Goodbye, moon. We're gonna explode you. All right, next suggestion. Collide Ganymede and Titan and then terraform it. Okay, I'm down for that. That sounds cool. So what we're gonna do is we're going to add Jupiter's moons into the simulation. And it was Ganymede and Titan, right? Okay, here's Ganymede, which is very, very large. So now we throw Titan into Ganymede. All right, here we go. Here we go. Collision. Okay, Titan got absorbed into Ganymede and it should deliver all of its atmosphere and methane into Ganymede. Okay, we got to make sure that Ganymede stays in orbit. Okay, looks like it does. Nice. Now we're gonna terraform it. We need what's a good like combined name? Like we need like our couple's name for Ganymede and Titan. Titanamide? Is that how you would say it? Okay, that kind of goes hard. Let's let it cool down, you know, it's been through a lot. Titanamide. Titanamide. Nice. Now, terraforming time on Titanamide. We need Earth-style atmosphere. So what we should do is replace... No. Earth atmosphere pressure. Okay, so that should give it an Earth-like atmosphere. And now we have 9.7% chance of life. We're gonna want the ocean... See how the ocean's made of nitrogen? That's bad. We need to cool it down. 17. Okay, ocean is made of... Why is the ocean made of nitrogen, dude? We need the ocean to be water. Okay, vaporize the nitrogen. Add new materials. Ocean, we want water. Okay, why are none of these water? Nitrogen, carbon dioxide, hydrogen, helium, methane, ammonia, oxygen, argon, sulfur. Why is there no water? Okay, that's not water, is it? Where's the water? The mantle has all the water. What is wrong with this planet, dude? All right, 10% chance of life. Is that enough? Is that terraformed? Earth has an average temperature of 14 C. All right, we'll make this one 14. Hey, maybe we just need to give it some time, you know, for that water to leak out of the mantle. Okay, it is not changing at all. 10.9. Add the vegetation on. I'd live here. Watch. Boom. Went green. Atmosphere. Make it blue. Oh, it's so thick. Titanamide. There it is. Give moonlit. What? A moon on a moon? We would have to give it literally a random asteroid to have a chance. Okay, there's a moon on Titanamide. If it's 10% everywhere, there's probably 100% chance one spot is life. I think it's 10% that life exists at all on the planet. I don't think that's how that works. Yeah, there's probably not life, but 10%, I mean, we'll take that. All right, next suggestion. Make an oil planet for Uncle Sam to harvest. I got you, dude. We're gonna keep our system here. We're gonna make a planet that is just made of oil so we can go colonize it. All right, we need it close proximity to Earth, you know. Let's go random rocky planet. We'll put it between Earth and Mars for Uncle Sam only. We need it to be made of oil. What is oil made of? What's our closest thing we could do on here? We have all of these. Oil is made of oil. Oil is made out of freedom. What is crude oil made of? Nitrogen, sulfur, and oxygen. All right. Those are the only three we're gonna have, okay? Mantle, nitrogen. Put some nitrogen in there. Okay, that ain't working. Liquid methane's the closest. Yeah, you're right, probably. Okay, ocean, methane, ocean. Okay, I don't know what the deal is with not being able to add materials. So I think what we do, you add an ocean, cover it completely with water, and then we go replace all water with methane. Replace all water with methane. No water for you. only oil. Okay, ready? Go. Okay, why is it blue? Is liquid methane blue? I'm Googling it. Liquid methane color. Colorless, odorless liquid. So it would just look like water. Why is it light blue? Turn the water into brown. I got you.
What an interesting ocean of liquid cow fart.
What an interesting ocean of liquid cow fart. That looks like oil. Crude oil is not black though. It's like a brownish. How about that? As we go in to land on our oil planet, we're gonna be rich. All right. How do we feel about our oil planet? For Uncle Sam, the aliens have dropped this off for America. How big is it? It's bigger than Earth. We're gonna have all the oil you could ever imagine. We're gonna crash this into Earth. This is what Earth has been missing, everybody. Uncle Sam. Where's Uncle Sam? Here he is. The oil planet. There's a giant ball of oil in the sky. It's bigger than Earth. Okay, we're replenishing the Earth's oil. All right, well, it just absorbed the Earth. Uncle Sam has taken over. Earth is now a ball of oil. Get rid of the atmosphere. Oil lakes. Earth is covered in them. That's so bad, dude. All right, there you go. There's your oil planet.
How many Plutos can you destroy to fragments in 60 seconds?
Let's find out, shall we? 60 seconds to destroy as many Plutos as possible. All right, let's line them up. Wait, hold on. I just need to fill all of this because I can just laser at it all. 60 seconds. I can destroy all of these. All right, I gotta do like slow motion time. Otherwise the Plutos are just gonna all destroy each other. So we're gonna go like super slow motion. Is lasering allowed or do I have to explode two of them? All right, we're almost done with this. All righty, you guys ready? The prediction will be, can I destroy all of them in 1 minute? Yes or no? Okay, we got a little bit of lag here. We're gonna need the time to be going very slow so that the Plutos don't crash into each other. How slow is that? Oh, that's still an hour per second. So slow it down. All right, you guys ready? 86% of you think yes. Here's the timer. There you go. There's the timer. Okay, ready, set, go. Destroy, destroy, destroy. I'm gonna keep lasering, and then as soon as the time hits 0, I'm gonna unpause, or I'm gonna stop lasering, and then we'll see what's left. Get them all, get them all, get them all. 8, 7, 6, 5, 4, 3, 2, 1. Okay, stop lasering. I am done lasering. So now the question is, once we speed up time, how fast or how many will be left? Oh boy, it's so laggy, dude. Now they're all pulling into each other too. All right. Hey, they're all destroyed. We didn't get them all. I'm really sorry to the believers, which was most of you. I did my best, and many of them did get destroyed. You can see if you count all the names, most of them got destroyed. All right, let's find another one. Make Sedna a star. Okay, that's an easy one. Let's do that. Okay, here's Sedna. Easiest way to make something a star is just turn up the mass until it stars. Here we go. Gas giant. Star. Bigger. Bigger star. Bigger star. 2 suns. Keep going. Oh, okay. We killed it. All right, well, there's Sedna as a star.
Make Venus and Earth binary at Venus orbit and see what happens.
I'd be down to make Venus and Earth binary at Venus orbit, see what happens. Let's do that. All right, there's Venus. So delete Earth. Goodbye, Earth. All right, here's Venus. Venus and Earth are very similar in size. So the binary should work beautifully. Let's go like maybe this distance. Okay, so now Venus and Earth are orbiting each other out at Venus's orbit. All right, the prediction is going to be, so Earth and Venus are binary. Will life likelihood on Earth drop below 85? So yes means it will drop below. No means it will not drop below. Okay, we're letting this run. So Earth has moved up to where Venus is, closer to the sun. It's binary with Venus. I don't know if how much that affects life likelihood. Usually Earth is 92%. So is it going to drop below 85? All right. 66% of you think yes. Let's see. Is it below 85? It is. 88.6. Should we let it keep dropping? I think we probably should. That seems the fairest. Let it go for a long time. You know, it is going to drop. Because we're trying to see a stable number here. When's it going to stabilize? It's still dropping. I thought it would have stopped by now. Is it just going to kill everything? Oh, whoa. Earth is not having a fun time here. Yeah, it is going to kill everything. Okay, well, I thought Earth would like maybe be a little hotter, but I didn't think it would literally die. Yes, it will drop below 85. Crash 5 suns into Pluto. All right, I'm down for that. 5 suns into Pluto. All right, here is Pluto. The worst object ever, probably. 5 suns into Pluto. It's gonna die immediately. 1. There goes the first one. Let's see the collision here on the first one. Here we go. Pluto. Okay, why did it not crash into Pluto? You know what? We're going closer. Whoa, something definitely happened to Pluto. There we go. 1. What happened to the system? Okay, we destroyed everything. Put Ganymede in Jupiter's Roche limit. I want to see that. Basically, we'll make Ganymede close enough to Jupiter that the moon starts getting ripped apart. Okay, so here's Ganymede. Okay, so let's move it. Pause time. I just want it really close, you know? Probably like here, and then we auto-orbit it. Okay, that ain't gonna work. You're gonna crash into it. Orbits. A. Okay. Oh, okay, there it is. Roche limit starting to destroy. Basically, the gravity gets so high because Ganymede and Jupiter are both so massive that the gravity, like the part of the moon that's closer to Jupiter, is getting pulled harder than the part away from it. So it actually rips because the gravity trying to pull it apart is higher than the gravity that keeps it together. And then looks like we're going to develop a ring system on Jupiter. All right, we have made a ring on Jupiter. 2 black holes the mass of the sun where the sun is. The prediction will be, okay, does Earth after this survive 100 years? We'll say if the likelihood is above 10% after 100 years, that counts as survival. So we are replacing the sun with 2 black holes the same mass as the sun. All right. Okay. So here's what we do. Delete the sun. Take black hole 1 solar mass. Put it here where the sun was. And then binary balance motion on another black hole. So those black holes will be orbiting each other in the center of the solar system. And the prediction is after 100 years of this, is Earth's life likelihood above 100%. Couple things to keep in mind. Earth will have no star, so no more heat coming in. Also, the gravity pulling is going to be twice as strong, so it should affect the orbits. It's not going to like suck it up. Okay, most of you thought no. 90% of you think the Earth will not survive after 100 years. Okay, so in the simulation, it is 2016. So we're going to 2116, okay? Earth's life likelihood is currently 92%. Let's see. Okay, yeah, you can see the gravity is a lot stronger, pulling the planets way harder. So it kind of makes all the planets get this elliptical orbit. Okay, let's speed up time. I'm going to clear the asteroids so we can run this faster. We're going to the year 2116. Oh, what happened? Earth got launched out of the system. It could survive. Let's see. What's it at right now? Oh, it's so dead, dude. 66 still. Dude, it could survive. We're waiting till 2116. Okay, it's dropping. No way Earth survives this. That's insane. We're at the year 2060 about. We got to go to 2116. I don't know if it's going to make it. Dude, it's totally going to make it. We're at 2105. No way. Earth could survive at least 10% in rogue interstellar space. 2116, 36% chance of life. That's impressive. Oh no. How did you get enough chips? How did you do it? Oh my gosh. There's no way you actually did that. Oh boy. Alrighty. That's atomic. Oh boy. I'm a little worried. I'm not gonna lie. All right, should we do the atomic wing first? I'm scared for my life. I'm not gonna lie. Atomic. Oh my, that's really spicy. Oh my gosh. The power is not very good. Oh, it doesn't go away. It's so bad. Go get some milk. I might need to, dude. This is bad. Oh, it's so bad. I need milk. I don't have any milk. This I'll have to do. Oh, it's actually so bad. Don't ever buy that. Just one of those did that to me. Dude, this is gonna be so bad. Oh my gosh, I don't think I can do it. I don't think I can do it. I'm being for real. It's so bad. Oh, I can't. I'm gonna throw up if I eat anymore. I'm not even joking. Throws up all over his setup. I feel like I'm going to. I'm not even gonna lie. Oh, the ice cream's not even helping. All right, thanks for coming. Goodbye. Spaceship YT, we're working on some fall stuff right now. It's not up yet. We're making some new merch stuff. Should be pretty cool. Spaceshipyt.com if you want to see what's up right now.